PhD in chemistry from Queen's University and a Bachelor in Physics from the University of New Brunswick. Today I'm going to run through a few undergraduate level physics questions. So here's our first one. What is the relation between angular velocity and linear velocity? So this would be, I'm going to test how well I can draw a circle here, but this would be referring to in circular motion. We have some radius for the circle, and the linear velocity was actually kind of perpendicular to that circle, but the linear velocity would be perpendicular to this radial line, whereas the angular velocity, the angular velocity would also be perpendicular, but it runs around the circle. And so the way that this expression is derived is by considering similar triangles. And so if we consider a small wedge of angle d theta, then each of the arms is r. And so this is our dx down here, or up here, sorry. And we can rationalize what that's going to be based on sine laws, actually. So if we call this angle up here phi, then we would say that r over sine phi is equal to dx over sine d theta, or dx is r sine d theta over sine phi. Now if we remember, inside a triangle phi, so if we consider this to be it's a triangle with both sides are r, so both these angles are the same up here, so those two angles are the same, so they both have to be phi, which means that our angle identity is 2 phi plus d theta equals 180. And so now if we take the limit as d theta goes to 0, then phi goes to 90. So then in our dx expression, as d theta goes to 0, as d theta goes to 0, sine d theta goes to d theta, and as phi goes to 90, sine phi goes to 1. 90 degrees, obviously. So I'll keep degrees on all these. And so then that means that as d theta goes to 0, our dx goes to r, say one thing and write a d, okay, r d theta. Alright, so that means that that in there is r d theta. So if our dx, if we recall, v, our speed, is just dx over t, dx by dt, which is r d theta by dt, but d theta by dt is omega, so r omega. So then that is our relation between our speed and our angular speed. V is our omega. And okay, so then in the solution here, yep, and then so V is our omega, and then they also gave it in when the angular velocity is in RPM. So yeah, so this is in either degrees per second or rads per second. But when it's in revolutions per minute, you need to consider that a revolution is 2 pi radians, and a minute is 60 seconds. So solution is correct. I just added a couple extra little things.